tests. So, today we're going to learn about variables, don't freak out, it's okay, and how to draw a graph. So, well, how to draw a graph in science. It might be different in some of your other subjects, but we're going to focus on science in particular. So, obviously. So, first, a variable is something that's able to change. So when you do an experiment or a practical activity, anything that can change is a variable. Now, there are three types we're concerned with. First is the independent variable. Now, quick note, when I was writing this up, I wrote independent, it's independent with an E. Doesn't matter, fix it up on your own. So independent variable, or we're going to write this down as IV, is the variable that you change, okay? So what that means is it changes all on its own, okay? You change that and that's it, that's all it takes. It changes independently of all of the other ones, which we'll get to in a second. So the independent variable is the thing that you change. That's the thing you're testing. So you're testing if time has an effect on the temperature of water when it's heated, then the thing you change by allowing it to continue on is time. Dependent variable, dV, that's the one that you measure, okay? So it changes or varies because of what we've done with the independent variable. So that's what we're testing there. Now, that's what we're measuring. Now, in the experiment we did with boiling water over time, the dependent variable what we measured was the temperature. Control variables, they're all the variables that you keep constant, you don't allow them to change. Now, you do this because it makes it a fair test. So here we've got volume. If we have different amounts of volume, we don't know if we're testing the time or the volume. It could go either way, so we keep it the same. The Bunsen burner, we keep it at the same place on the same setting because you don't know if changing it around will affect it. And if you change it around, you don't know if you're testing the location or power of the Bunsen burner or the independent variable, which was time. So the height that or the depth, I suppose, that the thermometer is submerged into the water, we keep that constant because the depth might change it. Now, if you wanted to see how the depth of the thermometer changed the temperature reading, well, the only thing you would change would be the depth of the thermometer, and we'd keep everything else the same. So that's that. So that's the first step we're interested in. The next one we're going to look at is how to draw a graph. Now, there are rules for drawing a graph so that we all draw graphs the same way. And the reason we want to do it the same way is so that you can grab any person's graph in the class or science in general and it will make sense. Okay? So first, always make a line graph. Always. Unless you are told specifically otherwise in science. Always do a line graph. Title, they all need a title and it should be the format of the dependence of insert dependent variable on insert the independent variable. So for example, the dependence on temperature, so how temperature depends on the dependence of temperature on time heated. So the amount of time we heat the beaker, what happens to the temperature, okay? Always label the X, which is the horizontal axis, and the Y axis, the vertical axis, with the units, okay? This one goes in with rule 4 at the same time, so they go together. The y-axis is always the dependent variable, and the x-axis is always the independent variable. So, the x-axis, which goes this way for our graph, would be time, brackets, seconds, that's the unit. The y-axis would be temperature, brackets, degrees Celsius. You see what I mean? Like that one there is the independent variable, dependent variable, sorry. That one is the independent variable. They go together, okay? Now, always make a line or curve of best fit. Now, two things. One, it's the average path through the dots. Two, it cannot go beyond the dots, so either before or after. Don't extrapolate, don't make it bigger than it was before. And do not ever join the dots, not in science. That's a different type of graph. The scale needs to be consistent and large as possible. And what that means by consistent is that the gap between 1 and 2 needs to be the same as the gap between 5 and 6. It's still 1 unit. Okay, and large as possible means take up all the room we give you. And finally, this is what a good graph looks like. Okay, you have the units and the label. You have a heading in the right format. You have a consistent scale all the way along. You have dots. Now you have a choice between dots or little crosses. I personally prefer the little crosses, but it's up to you. And here we have a curve of best fit. Now see, it doesn't go through every dot, but it goes through the average path throughout the dots. Okay? Alright, that's it. That's our graphs. So, yeah.